Hello, you are welcome back to machine learning course. Now, if you have if this is your first time, you should try to find the former class on introduction to machine learning, where we defined machine learning, supervised learning, unsupervised learning, um, and reinforcement learning. So because here we are going straight to demonstration. All right, and we have some previous classes on Python to know that we are using Jupyter. We are using Jupyter from Anaconda. All right. So the first thing, as with any data science project, is to import the required libraries. All right, so we are importing pandas, numpy, matplotlib, sklearn datasets, and some specific libraries from sklearn. You can see them here. All right, so once you are done, at first you might not know how many libraries you'll be needing, but as you progress, as you walk step by step, you will be needing those libraries. You can install them at the points where you need them, or you just bring everything to the top and then to install. So Control Enter to run this. All right, I am running this because I have run some other things before. So this is number 47 because I have run some other things before now. All right, so now what we need to load the built-in data sets. We're using a built-in data set, and that is the diabetes data set. Now, when we load it, because it's in a non-py form, we convert it to PD. That's a PD form. Then we add the target data sets into it. All these are just cleaning for the data because I know that the data sets came, the way it came not so cleaned, So that's all this I am doing. All right. So if I run this, the head, okay. So this head line gives me the first five rows of the data sets. So you can see the index 0 is row 1, index 1, row 2. Python starts counting from 0. So it gives me the first 5. If I use head.tail, it will give me the last 5. You must be used to that now. Otherwise, you go back to the previous Python courses and to learn those. Now, for the variables we have here, don't forget the diabetes. It's a diabetics data, all right, but it has been standardized. You can see age is 0.038, blah blah blah. It's because it has been standardized. So now about the data, the target variable is target, so you can see targets. The target is the variable we want the regression model to predict. Then the meaning for in this context, it represents a quantitative measure of diabetics disease progression 1 year after baseline. All right, so now this can be anything. If it's a business data, it might be profit, it might be deficit, it might be anything, it might be operations cost. Depends on what you want to predict. The target is always what we want to predict. All right, so here, so in interpretation for these targets that we have, higher values means more severe diabetes progression, lower values mean less severe progression. So looking at these targets here, the higher the severity, the lower the non-severity or the ease. All right, so the features in the data set, the features are the rest of the variables. So this is a target variable or dependent variable, while the rest from H to S6, they are the independent variable. From H to S6, they are independent variables. So the meanings, I have written them clearly out here. We have the age for age of the patients, sex, biological sex of patients, BMI, body mass index, and so on, BP, and you can see the summary here. Then why is data commonly used? It's a common data set to illustrate regression models because it is already cleaned and all of that. All right. So now after importing your data, one of the things you need to do is to explore the data. You check the height, the width, the number of observations you have. You check for missing values and so on. All right, so let's do that. Check number of rows and columns. We use df.shape. That's 442 column 11. That means 11 column and then 442 rows. Check for missing values in the data sets. So what we do is we write df is null. If you remember that in Excel, is null.sum. Then you can see for the first variable, no missing value. Second one, no missing value. So the last one, target value, no missing. So this is good. It is a clean data like we have already stated. All right. So view statistics summary of variables. So if you do df.describe, that would give us the statistics. The mean, the median, and so on, the standard deviation, the minimum, the maximum, 25 percentile, and so on. So it gives us the distribution of the whole data set. Now, these are all part of EDA, Exploratory Data Analysis. So now another thing we need to do is to visualize the target distribution. Visualize the target distribution. So that means that target, that dependent variable, we need to visualize it. We know it is in numbers, so we plot a histogram for it. So you can see it is not perfectly normally correlated. It is skewed. It is skewed. So that this output informs us, tries to tell us or give us an idea of what models to use. Now that we know that this is not a it is not close to normalcy, then we know that we do not need a normally distributed model. We need a model for non-normal distributed data. Okay, so we need to visualize the relationship between feature and targets as well. So BMI versus disease progression. So you can see a fitted line can pass through them, but the variations are quite much. All right. Then we prepare for the modeling. So to go into the modeling, we need to divide the data into two. Not the training sets yet, the features and then the targets. All right, so we'll do that, then end this video and then start again from there. So how to do that? We use capital letter X for the features, for the independent variables, and we then put this df.drop targets. Every other thing but targets, is what we are doing here. Drop targets, axis equals 1. Then small letter y, which is the independent variable. We are using capital letter X, small letter y, because in the statistical equation, that is how it is. All right, so we have df targets. So the y is just bringing out the target variable from the df, from the data frame. That is what these two are doing. Then if you look at the shape of the two, we would have the number of rows to be 442 for the feature and 10 columns for the feature, while for the target we have 442 for the features and nothing for the column. Yeah, nothing for the column. Here we have 10 columns. Here we have, if you remember, everything was 11 columns before, but here we have 10 columns. Here we have 442 rows. So 442 rows and no column. That means we have just one column. All right. So we'll end this here so that the class will not be too long, and then from the next data we train the model and then run it.